screen sharing?
I'm already sharing my screen, but it is
Actually,
not
but we
showing.
are unable to see your screen. Like it's showing the same window like Hadoop meeting as assigned.
Okay, let me once restart. Please be
Okay,
online.
we'll be on.
Going forward, a small difference in between Hadoop commands and Linux commands. Just we'll be looking on forward what all the differences and what all the things we are can able to Hadoop is going to give it. So about me, coming to me, my name is Mahendra, and I'm having 6 years of total IT years experience based on the product-based companies. Right now, I'm having 3 years of overall experience working on big data. Hadoop. So I was working as a Hadoop architect. Even my position is a lead, but I'm position. I'm leveraging on all the architecture. So regarding to coming to our agenda today, we'll be checking on what is big data and what all the real-time use cases we are gonna see in the big data terms, and what Hadoop, and we'll see Hadoop versus RDBMS, and job market will not see right now. It's based on India, so that would not fit you right now. So first four topics will be our agenda. We'll cover it up today and tomorrow, all these terms regarding to it. So what is it in your thing? What do you think of big data? Have you heard of big data, and what is?
No, I don't know anything about it. I was just going through the terminology, little bit of
You might
what
be
is the
having
related
some kind of
terms and stuff
understanding,
like that.
from your side. What is big data, and you might heard something like it is a big kind of data, so you can able to handle such kind of big requests even in the faster in real-time scenarios like that. So the main thing is the data. Big data is nothing but data which is even in the large amounts of data which we can able to process that in our environments and get the results from that particular data even more faster than what we are getting from our earlier legacy systems like traditional RDBMS or all other systems. We can leverage with the big data even in the faster way than before. So the main thing is we'll see what all the data, what is data. So while it was from the dawn of the time till 2003, there was only some exabytes of data itself, 5 exabytes of data till there. So we were having only some MB of RAM, 1 MB of RAM or 2 MB of RAM is more enough in that kind of time. So we are just using a dot matrix kind of things all the way. So data was not much at that point of time. Coming from
Can I actually ask you something? Just wanted to understand the basic stuff.
Yes.
So when is it this started? By 2003 or which year?
Yes, it like from 2003 to 12, it was like it's been increased to 2.7 because internet revolution came in from 2003 or 1990, 2000 starting, it started up internet revolution and all the data. So we were using all our servers. So at that point of time itself, internet like GoDaddy.com and all those sites came in, and they are really producing the data at that point of time.
Okay, and what is the latest version? How it is like?
What is the version?
Yeah, the latest one. Is it something like that, or it's just the?
No, it's like increasing. So normally I say, if you think of IBM itself, earlier it was IBM machines were having only if any of the homemade machines, if they are giving home computers, they were giving only some MB or 10 MB of hard disk, no, 1 GB of hard disk and 1 MB of your RAM will be available, and at the point of time when you bought your computer. Going forward, the revolution started, and now we can able to see with our systems having 32 and 64 GB of RAM in our personal computer itself, which was not available at that point. So even in our basic computer itself, we are storing our data where it's like terabytes of information we are storing in our data in our personal computer. So everywhere it's data itself, right? So think of if I'm alone itself producing some terabytes of information from my end. So computing all the data across the world, it would be like zettabytes, or it will be going off the chart, right?
Yeah.
So at the point of time, 2000, from 2003 to 12, it's like increased a little bit, and it started up like till 2012, whole world data was 2.7 zettabytes. So it was like 500 times more the data from the dawn of time. You can see only
Yeah.
a chunk of data would be present at the point. So later on, from 2012 to 2015, it's been increased thrice from what it was in 2012. It's been increasing exponentially, and it is increasing randomly in a random pace. So data is been increasing, and we are producing the data even more faster than what we are thinking of in the earlier days. Earlier, maybe in 12 years back, you might have not having the same configuration what you are having at present, and you might not have experienced the data or else producing the data at the same pace than 12 years, right?
Yeah.
So in this time, it's been evolution takes place, and data revolution came in. So everyone is looking on data as an asset. Even the companies are looking their data as an asset. And at this point, whenever big data came in, some of this, there are three kinds of data whenever we are thinking of data. Data would be either structured, or it can be semi-structured or unstructured data. So we'll see on what is structured data. Structured data is nothing but whenever we are structuring a data, say for example, if I'm having a particular structure for my data, say if it is a column separated value or else it's an Excel format. So it's formatted and it's structured. Or else say take the example of database tables. Those are all will be comma separated values, right?
Yeah.
In the back end, whenever we see the data in a database, it will be a comma separated value. So it's a structure format. Say take the example as structured with comparing that with the database tables. So all of them, if it is a semi-structured in the sense XML, take the example of XML and all the other kind of data. Those are all semi-structured, which are not fully structured. It's like a semi-structured data which we can take up across. And coming to the unstructured data, which is kind of 92 more percent of the present data is unstructured data. That's where most of the other we are looking on for Hadoop and all the other tools which we are looking out for to leverage with unstructured data and get the useful insights from that data. Say take the example of unstructured data. data could be from YouTube, or else even the video data is the data, and even signal information, Facebook data, Twitter data. We can able to get all the Facebook data from, you can get all the information, like what all the, if you are having IBM page or your own page, I have posted something like some job opening or else related to the news. How many has subscribed to that, how many of them are commenting on that topic, kind of thing. I can able to get that information from Facebook and can load it up in my system, which could be more, right? Even in the real time, it could be thousands of lakhs of comments will be coming across if it is a public system. Everyone can able to access that particular comment, and they can able to reply on top of it, right? So everything we are producing in any of them is a unstructured data, which is, so for example, if I'm uploading a video on top of YouTube, so I have uploaded one of the data which is like MPEG, or so normally we cannot have any structure for that. We can able to decode that particular videos using any of our codecs itself, right? So those are all comes under the unstructured data. Even say for example our logs you might have in your day-to-day life, you will be seeing all the server logs, right?
Yeah.
Log information and everything. That also will be taken as one kind of unstructured data itself, because data will not be in the same fashion, right? So if I'm giving some request, I would be getting some response, and if some exception comes in between, and you will be getting all the exception message. It is not structured. It can be of any type in there. So, but from that log kind of data, we can able to get more insights on top of it. So we can able to find what all the applications we have seen in. So users are looking on for this this application, and what all the conditions they are looking on, and why these exceptions going on. We can able to troubleshoot all our application issues and able to give best of our application to the users as well at that point of time. So say for example, for in our daily use case, one of the use case for the big data is like, take an example of a small airline jet which will be collecting nearly 10 terabytes of sensor data for every 30 minutes of flying time. So think of it like a small airline jet is collecting this much of information or data every 30 minutes. And even if you take off New York Stock Exchange, which would be dealing on 1 terabyte of the trade data every day, it would be very large amount of data. So if they want to analyze that particular data every day, 1 terabyte of data every day, that would be with normal traditional systems, that would be a problem for them to handle such kind of requests, right? Even if you are going to take that as a real-time scenario, then that will be very much burden on, or else we cannot able to handle such kind of request with our traditional systems. So that's why big data, to handle such kind of big data concepts, Hadoop came in. These would be traditional, coming to the structured, semi-structured, and unstructured. These are all the different kind of things. Say, for example, you can see the trends going on from earlier, from the starting of the time till now. We are using the relational systems. So from starting, it was only the relational data which we are producing, only creating on the tables, all the things. But right now, it's like application data is also going up, and we are getting unstructured and complex data. It's been exponentially increasing. in exabytes and terabytes, we are increasing our data, application data as well. So comparing that, uh, taking that aside as a perspective of data storage and the thing, we'll look on with the transfer rate of data, which in terms of storage and analysis, we can see that from transfer rate has been not that much increase in terms of data storage and analysis. Earlier it was transfer rate. We are increasing our data in an exponential way, but not our data storage, right? So still we are confined to 64 GB of RAM or 128 GB. Even for the servers, we are handling max of 256 gigs of RAM, right? So we cannot go on top of it. We cannot have 1 TB of RAMs. It's not available till now. So it's not increasing in that random pace compared with the data. So to seek such kind of transfer rate is nothing but if I'm having even 1 TB of hard disk, the transfer rate or the seek rate to get the data from that particular location of the that disk, hard disk will be the same compared. That would be um, measured in cycles or indels. You might heard of those terms in content management, while the disk rate and seek rate and everything. So say take the example of if I want to read 1 TB of data with a single machine, I'm having each of them, my channel will be 100 Mbps and I'm having 4 IO channels. I want to read 1 TB of information. And if the same thing, I'm doing it with 10 machines to read 1 TB of information. So what would be the faster one? So if my one machine is taking 45 minutes for reading the data, 1 TB of data, so what would be, it would be taking 10 machines would be taking only the 10th amount of data itself to complete that reading. So the main thing is like it's like distributional system. If I'm having distributed system, comparing that way, we can able to handle any kind of large amount of data and can able to handle the request from that on top of the data even faster than what we are expecting from normal single systems or any of the other systems.
So
Because
basically this is 10 different storages, right?
Yep, seeming that just like an example I'm sharing you.
Okay.
So
No, I'm just asking, this example, you mean to say instead of one storage, 10 different file storage?
Yep, if I'm, say for example, if I'm having 1 TB of data here and I'm accessing that from one machine and I'm copying that to my machine, say for example, that, but if I'm having 10 machines using the same, copying the same data, it will be distributed across. So one might be taking 1 to 100 MB of data, second can be taking 200 to 200 MB of. They can able to chunk their data and they can able to read the data in a fashion, right? They can able to handle that, right? With the single system, everything has to be taken care by the single system itself. And the main issue is like we cannot go with the virtual scaling. Say for example, scaling in the sense I cannot scale my server or else my machine after a particular amount of size which I have reached. Say for example, if I'm taking 256 gig of RAM, I'm taking the full high-end machine for my server and I'm using that. I cannot scale it virtually anymore, right? I cannot vertically, I cannot scale it, I cannot increase my RAM because my hardware will not support that kind of cases. So that we will be treating it as a virtual scaling. If I take a single machine and I take the fully fledged machine and working on top of it. Say if I'm having 1 terabyte of data with 256 gigs of RAM, I can able to have such kind of even less results. But after that, say for example, if I want to increase my decrease my time of reading even more, I cannot increase my whatever the hardware, I cannot go further there. So that will be, there will be a bottleneck for or else there is a limit for in your vertical scaling with the single machines or any of the machines. But whereas in distributed systems, we will be having horizontal scaling. If even with the small systems, say for example, if I'm having 10 machines with only 30 GB of RAM, only small systems, just like our overall system which we are using in our day-to-day lives, then no, then also we can able to handle, we can able to, with one machines we can able to handle that with 10 machines. Even say for example, if I'm having full-fledged high-end machine, that would be way more costlier than what we are expecting. Say if I'm taking normal commodity hardwares, that would be very much cheaper than what we can go for with any of the high-end machines. Even in terms of we can able to handle such, if with 30 GB of RAM with 10 machines, I can able to handle say 10 machines. That means 300 GB of RAM I can have combined all my 10 machines, right?
Yeah.
That which is more than one machine, and comparing the cost with the 10 machines with the one machine, that would be even more cheaper than what a one machine is costing with high-end configurations, right?
Yeah.
So that's the reason most of the companies are going on for horizontal scaling also. And horizontal scaling is already present in one of the traditional systems, which distributed systems, and also like even Oracle, we can have a distributed mechanism, but it has its own concerns. It cannot able to handle after 256 nodes. Say for example, if I'm having 256 nodes of data for my database or data warehouse environment, so post that I cannot have everything in a single instance. I have to take another instance of my Oracle DB, then I have to go through and I have to populate the other instance.
Yeah.
So if I want to get the data which is whichever is present in the other data storage or data instance, I have to go into that instance and get the results and then take the results onto this new system and then have to compute those results to get. So these are all the things. There are confinements which Hadoop has been taken care of. So coming to the drawbacks of our traditional distributed system, earlier there were already having distributed systems to handle such kind of requests in the parallel way. So the main issues or drawbacks with the traditional distributed systems would be like there will be node failures, data loss, node failures in the sense if at any point of time. So see, any of the commodity hardwares will tend to fail at any point of time, right?
Yeah.
Will be need to find out the issues and we need to reload the or else restart it, or if at any point of time some disk fired up. So say for example, if my hard disk fired up in my server, I have to go, and that is inevitable. We cannot do anything regarding to any of, even with the high-end machines also that can happen. So node failures we cannot handle, and that was the drawbacks with the traditional distributed system. Even the data will be lost at any point of time. If my node is failed, means my data will be lost across. Whichever the data present in that particular node will be lost. And also the network bandwidth issues and scalability problems. In the case of, say, take the example of the Oracle DB itself, it can able to scale up to 256 nodes itself, not pass that. We cannot able to scale it up. And high synchronization should be happening across all the nodes whenever we are processing any of our data in the traditional distributed systems. So to handle such kind of insight and also knowledge of that, we are having Hadoop in market. So these are all the things which we have discussed today, which Hadoop can able to handle such kind of all the drawbacks which Hadoop is handling. It can able to handle the big data, and it can able to handle different kinds of data. Even relational DB can able to take only the structured data. Hadoop can able to handle structured, unstructured data, or semi-structured data. Any kind of data, Hadoop can able to handle it across on top of it. And even with the big, say for example, taking the example of big data in terabytes or exabytes, even in that way, Hadoop can able to handle such kind of data even more faster way.
So how you are using the term big data and Hadoop? So how you differentiate that? What is it the same thing or it's two different things?
It's two different things. Big data in the sense it's like comparing the data. Say for example, if I'm having 10 or terabytes of data, that would be considered as a term of big data. Just normal jargon. Big data. Data is big, so we are taking it as big data. Okay. And to handle such kind of big data and the type of data, say for example, if my big data is present, the data is structured, then it is a structured big data kind of data. Data can be of structured or unstructured data. So it can be of different types of data, and to handle such kind of big data, I'm having Hadoop architecture, which is a tool to handle
This data.
big data. Yes.
And just to clarify, so we are not using any traditional databases along with this.
We can because we can able to use kind of if you want to use Hadoop, it is in starting phases. If it has to we have to migrate the existing data from all the databases to onto Hadoop, right? So we will be using some of the connectors to handle such kind of RDBMS also. Like say for example, Scoop is one of the tool in the Hadoop ecosystem which can able to handle the data of
so you
transfer.
will be explaining this in the classes, right?
Yes, yes. All the tools we will be having. So Hadoop is one tool which can able to leverage with the big data. There are so many other tools also in the market to handle coming up across in latest technologies. With Hadoop is one of the tool which can able to handle the big data in most efficient way and in faster way. And the main concept for it is like it's open source. That's the main reason for it, to get most of what all the things we are listening across. It's mainly because Hadoop is open source. If it is, say for example, if it is some patented or some software which is not open source, then that Hadoop would not got this much of uh, what all the things which we are listening across, why we are learning this. So coming to the Hadoop, so it was started up by Doe Cutting. So he's the creator of open source search technology, and also he's one of the contributor and creator of Apache Hadoop from. So we will see how it started. So in 2004, Google published a uh, white paper for on their own system like Google file system, and MapReduce paper. They have released white papers. on top of on the technologies which they are using at the point of time. So after that, releasing the white paper, Nudge, they have taken that um, concepts from the white paper and they have started started working on the Hadoop HDFS, which is the core of the Hadoop file system. HDFS, Hadoop Distributed File System.
File systems, okay.
So it was originally derived from the GFS, which is the parent of Hadoop itself, because so most of the topics which are taken care is from the GFS or Google file system itself. So then Hadoop started off as a project in Apache Foundation, and it has become a full-length project, major project in 2009. From 2009, Apache Hadoop has become one of the main projects of Hadoop, open source projects. So you can even find all the source code for Hadoop, everything from Apache's site. Or so if you want to find what exactly is in Hadoop, you can, if you are aware of all the technologies, you can able to go fetch the source code and get the internals of Hadoop also.
Oh.
It is open source, so you can able to handle such. You can able to contribute on top of it also. If you want, if you can contribute on top of it also. The main characteristics of Hadoop would be three V's. Whenever we are comparing any kind of Hadoop characteristics, it's like volume, velocity, and variety. Take a note of this. This is the main feature of it. Volume, velocity, and variety are the three kinds of data which we'll be looking across whenever we are looking on for Hadoop. Take the example of volume. If I'm taking from the term, if I'm having any kind of volume of data, say for example, if it is a petabytes of data or exabytes or terabytes of data, it's the volume of data which we are taking care of.
Okay.
And say for example, if I'm having velocity of data, say for example, I'm taking real-time streaming of data, if I'm getting some 10,000 hits per second, or if my system is getting populated 1 GB every second, or for every 30 minutes I'm producing some 1 terabytes of data, that would be treated as velocity of data, not with the volume.
Okay.
If we think 1 GB is small in terms of volume, right? But 1 GB will be big data in terms of velocity, 1 GB per second if I'm taking it, then it is considered as a big data itself, right?
Yeah.
So we cannot think of any of the particular volume as a big data itself. We have to take care of all these three V's, then only we can able to compare that as a big data. We can say 1 GB of data is a big data, comparing that in the velocity of data. So if I'm getting 1 GB of data every second, if I want to process that, that is a big data for me. Then that is a challenge for me, right, with the traditional systems. So comparing these three V's, and the other way one is variety of data. Say take the example of, if I'm having 1 GB of data which is structured and I'm getting it in 1 second, that can be handled in some way. But say for example, if I'm taking unstructured of data, then then I have to process it in a different way, right?
Yeah.
And even I can take it as a big data. Say
So
for example,
the combination we are
yeah,
thinking about.
the combination of three V's of big data which we can able to handle up with Hadoop. So we can able to handle the volume of data, even the data if it is big also we can able to handle up. We can able to handle the velocity of data also, even at any point of time if we are getting the data with the velocity, we can able to handle such kind of big data. Even with any kind of variety, we can able to handle it. So these that's why we have taken it as a summation of all the things, union of everything. We have taken intersection of the three V's. The main Hadoop key features will be like it's an open source. So that's the main reason why it has been, it's more popular than any of the other big data tools. Hadoop is an open source and it's a distributed technology. So we have seen that how the distribution environment will be differing from any of the vertical scaling. It's like horizontal scaling with any number of nodes I can able to handle up, and it's a batch processing. The key features, this is one of the main thing which you need to look across. Hadoop is a batch processing system. It's not a real-time processing system. You need to look across it. There are other tools in Hadoop ecosystem which can able to leverage with this batch processing. There are some other tools which can able to handle the real-time processing also, like Flume we can take off across, Apache Flume, which is one of the ecosystem present in Hadoop, which can able to handle transfer the data in near real time. So the main advantage or the key feature is like it can able to work across on normal commodity hardware also. We can able to use any of our commodity hardware, say for example with the small, say for example if I'm taking a minimum of RAM, I can able to handle, I can able to create a cluster with that, even with that small hardwares also. Because if I'm taking one small hardware, I want to handle, say for example if I'm having high-end machine of 250 gigs of RAM, so I can able to achieve that same processing and ability from, say for example if I'm having 200 node cluster with 1 GB of RAM itself, 1.5 GB of RAM, then I'm having the same ability of having the high-end machine with me, right?
Yeah.
So with the even minimum amount of even minimum cost effectiveness and everything, we can able to handle high amounts of data, and also we can able to achieve even very much speed results and everything on our systems, even with using our commodity hardware. And the other key feature of it is it's a scalable architecture which can able to scale across with thousands of machines also in the cluster. You can go up with thousands of nodes in your cluster in your Hadoop environment. It is a scalable architecture. And also coming to the thing which is a drawback in traditional distributed system. In traditional systems, it's like node failure is a common scenario. To handle such kind of issues, Hadoop is a fault tolerant. The key feature of it is Hadoop is fault tolerant, and it can able to handle any kind of failures in node failures, or it can able to handle any kind of node failures, data loss, and everything it can able to handle across. And
so we will be going into details of this terminology
yes.
later, right?
One by one we can able to deal with this in our classes, and I'll be showing you how it is fault tolerant, and we'll see it in. And high availability is one of the feature which is available in Hadoop. High availability in the sense at any point of time, say for example if my node is down, say for example take the example of the RDBMS or any of the traditional distributed system. If my data is present, say for example some 10 MB of data of my particular records are present in one system, in one location, okay. Say for example if my particular node is down for some time, I cannot access that particular data, right?
Yeah.
So that means my data is not fully available at any point of time. If my node is down, my data will not be available, right?
Yeah.
And coming to Hadoop, it's like at any point of time your data will be available. That is the concept of high availability. At any point of time, even any node is down, you can able to handle your data will be available to query upon. That is one of the key features of Hadoop, which is high availability. So any questions till now, or?
I have a lot of things in my mind, but I'm not asking anything today, okay?
Okay,
So
okay,
many
no
things
problem.
are there, but I know it's just the first introduction, so
Yeah,
you will be
we
going, you will
can deal
feel,
it up.
yeah.
Actually, I'm very much open for any of the questions. If you ask the more questions, I can go deeper into and explain you a lot more in that. If you are interested in asking questions, then that would be
Yeah,
more
after 2
useful
or
for
3
you.
classes,
Yeah.
I will be asking, because in the beginning I don't know how to ask the question. Even I
No,
have to read little more on.
no issues. This is between you and me itself, right? No one else in the class also. You can able to ask any doubts. Even you can farm your question in any way. You can ask me that. I can able to understand that, and I will try to give you that answer. I can able to make you understand that.
Okay. Okay, that's fine.
Feel free to
And
ask
if you
questions.
need to change the timing according to your job, because I am working from home, so I
Okay.
am available always at home.
So this time is okay for me.
Okay.
7:30
If you
in
wanted to
IS.
change anything, you can just let me know, because I
Yep.
have 4 kids there. Once they go to bed, I am free. And in the other, your evening time also, I am, even though I am working that time, I am at home only, so I can take the classes, no problem.
Okay, okay. If
So
there
if
are
you need
any
to,
such kind of concern, I will be letting you know
yeah,
through the
if you
chat.
have any plans or something, you can just feel free to tell me, okay?
Yep, yep. At any
I will.
point of time, if there are any kind of plans, I'll be intimating you prior itself on mail communication, or else
Okay, you can just
on
send me mail,
this.
or no problem.
Everything
I will be checking.
will
Yeah.
be communicated in prior itself at any
And one
point.
more thing, if I stop recording today and if I start recording tomorrow, it will not overwritten, right? It will be